Good day all. I warmly welcome you to Wanies Academy. All right, so I'm here to take chemistry, and the topic I'll be teaching today is states of matter. I'll say that again for clarity and emphasis. The topic we'll be considering today is states of matter, and the aim for this class is to teach about the states of matter, then the objectives. So the stated objectives for this class are as follows. At the end of the class, the student should be able to 1. Define matter, 2. Give the states of matter, then 3. Explain the properties of the states of matter, then 4. Give the typical examples of the states of matter. All right, I commence my class in earnest. All right, so before we go to states of matter, now I need to first define what matter is, right? So now when we say matter, what are we referring to? Now, matter can be defined as anything that has mass and occupies space. So anything that has mass and occupies space is called matter. So going by that definition, it simply means that practically everything in the universe is made up of matter. So most of the things, right, around us, right, most of the things in the universe can be considered as being made up of matter, right? For example, the food we eat is matter, right? The water we drink is matter. The air that we inhale is matter. Plants can be considered as matter, right? Animals can be considered as matter. Chairs, tables, clothes, right? All these substances, they occupy space and they have a mass. Even we ourselves, they can rightly be considered as matter, right? Now, however, bear in mind that I said most substances can be regarded as matter, right? Or can be considered as being made up of matter. However, that does not mean that all substances are made up of matter or all things are matter. For example, energy, right? Forms of energy like heat energy, light energy, and sound energy, they can't be considered as matter because they do not have mass and they do not occupy space, right? Then gravity is also another example of a thing that can't be considered as matter. So gravity is not matter. Then energy, right? Heat energy, light energy, sound energy can't be considered as matter, right? However, most things around us in the universe can be considered as matter because they have a mass and they occupy space. All right, so having defined matter and giving us typical examples of matter. Now let's look at mass. What is mass? Now, mass can be defined as the quantity of matter that is present in a given body, right? So the quantity of matter that is present in a given body is called matter. So the amount is called mass, rather. So the amount of matter that a body contains is referred to as the mass of that body. So more loosely, the amount of stuff present in a body can be considered as the mass of that body. Then there's SI units. In sciences, the international system of units that we use for measurement is called the SI unit. So the SI unit of mass is called kilogram. So the SI unit with which we measure the mass of a given body is called kilogram. It's called kilogram, right? So and this kilogram is usually denoted, right, with the symbol kg or the abbreviation kg. However, in chemistry, we don't use kilogram for measurement of mass. Since we are dealing with chemicals, we use a smaller unit of mass called grams. So, right, mass is usually measured in grams in chemistry, and this gram is denoted with the letter G. Right, since we are dealing with chemicals, so we use the smaller unit of mass called grams. And bear in mind that 1,000 grams, right, is equal to 1 kilogram. So you know that already. All right. So having stated this, now let's look at the instrument with which we measure the mass of a body. So mass is measured with an instrument called chemical balance, or what we call beam balance. All right, so I haven't talked about matter and mass. Now let's quickly go to what we call states of matter. So the different forms in which matter existed is called states of matter. And matter is known to exist in 3 major states or forms, right? So these are solid states of matter, right? The liquid state of matter and the gaseous state of matter, right? So these are the 3 major forms or states in which matter can exist in. So we have the solid states of matter, right? Then secondly, we have what we call the liquid state of matter. So there's also the liquid state of matter. Then thirdly, we have what we call the gaseous state of matter, the gaseous state of matter. Now, however, we have other states of matter, but they are not considered as major state of matter. For example, there's what we call the plasma state of matter, which is usually formed when gases are heated to a very high temperature. They now undergo ionization. So, but it's not a major state of matter. So there are three major states of matter: solid, liquid, and gaseous state of matter. So I want to quickly pick this state of matter and explain the typical characteristics of this state of matter. Now, let's look at the solid state of matter. Now, in the solid state of matter, but firstly, bear in mind that all these states of matter, they are made up of particles, right? They are made up of particles either in the form of atoms, molecules, or ions. So these are the particles found in matter: atoms, molecules, or ions. Now, in a solid, the particles are closely packed together and they are held by strong forces of attraction. So there's strong cohesive forces holding the particles of solid together. Therefore, there's restricted movement of particles in solids. The particles move, but they tend to vibrate about a fixed position, right? So now, having stated that, on the basis of this fact that the particles are closely packed, solids have a fixed shape in nature. So all solids have a well-defined shape that they can be identified with. Then secondly, solids have fixed volume. Then the third property of solids is that solids are incompressible. So you can't squeeze solids to a small space. So they are incompressible in nature. All right, typical examples of solid include tables, chairs, rice, beans, right? Books. These are examples of solids. Now let's go to liquid state of matter. Now in liquid states of matter, the particles are not closely packed like what we have obtainable in solid. The particles are further apart in liquids because they are held by forces that are not as strong as the ones we have in our solids. So therefore, liquids do not have fixed shape. So liquids will always assume or take the shape of their containers. They always assume or take the shape of their container. Then secondly, liquids are known to have what we call fixed volume. They have a fixed volume. Then lastly, liquids are also incompressible. So typical examples of liquids include liquids like water, like petrol, like diesel, like kerosene. All these are examples of liquids. Then let's go to the gaseous state of matter. Now, for gases, the particles they are held with little or no intermolecular forces. So as a result of this, the particles of gases are known to exhibit a very random or disorderly motion. So they move about in a disorderly manner. So on the basis of this, gases do not have fixed shape, they don't have fixed volume. However, gases are compressible in nature. So you can compress or squeeze gases to a very small space. Typical examples of gases include oxygen gas, nitrogen gas, methane gas, carbon dioxide or carbon 4 oxide gas, then carbon 2 oxide gas. So all these are typical examples of gases. All right. With that, we have come to the end of today's class. Thanks for watching. But remember to click on the subscribe button so as to come across more exciting and educative video. And also remember to share this with families, member and friend, with your family and friend. Thanks, and see you in the next class.